Hey guys, good morning. Thank you for the nice introduction there, and yeah, thank you for sticking through all this. So I'm sure, especially the morning after Cinco de Mayo, it's tough to get out here. But all kidding aside, I really am grateful for the opportunity to be able to be here and share a little bit of my perspective of what I've come across in the hospitals. Um, so what I'd like to discuss today is just some basic troubleshooting ideas or pointers that are geared towards you as the therapist. We're going to keep it super simple. I'm sure quite familiar with the majority of things that I'm going to be discussing today. But maybe there'll be a few tips or things that you can pick out that might be useful down the road. Yeah, a little bit about myself. I own a company called International Medical Equipment. We're based in Miami, Florida. We service and support quite a few different types of ventilators. Um, we're in the hospitals doing the work, trying to keep these units running for you guys to be able to keep doing your work. Um, Based in Miami, we what else could I tell you about ourselves? We also work with purchasing departments for the hospitals where we'll remove some of your equipment that gets end of life and we'll refurbish it and sell it off overseas. It's an interesting way for hospitals that have limited resources to be able to have access to the high quality equipment that we have here today and sometimes take for granted. So what I'd like to go over is just the general outline of what I'll be discussing and kind of just take it from there. So first we'll touch on the objectives for today's discussion. Then after, I'd like to give a general overview of how the ventilator works, more from the back end. So you guys are quite familiar with everything from the user interface and the front end, but I just want to touch on how that breath is delivered to your patient, everything that kind of goes on underneath the hood of the ventilator. And then as we go and walk through just the process of that breath delivery, I'll touch on certain anecdotes that I've come across in the field that I feel could be helpful to you guys on the road. So objectives for today. During this lecture, I'd like to identify and troubleshoot some common failures that occur during the short system test. So I'll get quite a few service calls for issues that really aren't vent failures. They're more just a procedural error or something quite simple that you can resolve yourself. Um, idea being that you can really save your hospital some great resources without having to call us up there to fix your ventilators or pull a ventilator from service just because of a quite simple thing. And these are issues that I've found not just on one specific ventilator or in one specific hospital. It's pretty common throughout the hospital setting. And I also want to touch on just some important points on proper equipment maintenance, kind of building off of things that were observed and learned during the initial stages of the pandemic. So let's get to it. You really have about 3 different service options for your equipment. Probably the first and the most excellent option would be service contracts directly with the manufacturer. Those are the people that are making your units. They're supporting it. They have the engineering backing. They have all of the resources at their disposal to be able to properly maintain your equipment. You have other options where you have your in-house biomeds who are also trained on those ventilators, and they're able to support them and maintain them as well. And one other option are third-party service companies like myself. We are a lower cost alternative to, say, a direct contract with the manufacturer. We have a little bit more flexibility as far as being able to service units that have been end of life by the manufacturer. So you have a little bit of a buffer or some option there, should you need some time before upgrading your whole fleet because your units were end of life. We'll work a lot hand in hand with your biomeds. Even ones that have been trained, they'll call on to us to help support. Sometimes they just have a backlog in units that are past preventive maintenance, and say JCO's coming around the corner, and you have to get them all up in compliance. So we'll step in and we'll help teamwork with them and get everything where it should be. So this discussion, I'm going to really do a generalized overview on the different components and how they work together to manage your breath delivery. So each manufacturer has their own design specifications, operating and servicing procedures. Really what applies to one ventilator doesn't exactly apply to the other. However, the general principle does remain the same. So as we go through the general mechanics on how the breath is delivered, I'll stop at certain points to give some anecdotes of experiences that have come across while servicing these units in the hospital. For today's discussion, I'll use the Puritan Bennett 980 to reference on how this breath is delivered, but it's not device specific. It's just a very common ventilator that I think might cover the majority of the people here. So here is the Puritan Bennett 980. It's manufactured by Medtronic. Excellent ventilator. It can be broken down into two components for the sake of this discussion. The user interface, which is the part that you guys are all familiar with, and then the pneumatic system, so the part down below it here. And that's known as the BDU, or the breath delivery unit. And that's really the heart of the ventilator. It's where the air and oxygen are mixed and where the gas flow is delivered to the patient in a precisely controlled manner. It's done through a network of various electronic sensors, fail-safes. We're not going to go into detail about that, but what I will go through is just the generalized chain of how that breath is being delivered to you, separating the module to the inspiratory and the exhalation. So here's a general schematic of the inspiratory module. So this in the red box is your inspiratory module. And it's where it's going to regulate, the air and oxygen. So it's going to be inputted a high pressure gas and pass through the module and delivered to your patient according to the operator's set variables. So it all starts with the supplied gas. So compressed gas from an external source, either the wall or tanked oxygen and air, enter the supply side of the ventilator. The gas supplied to that ventilator has to deliver a minimum flow of 200 liters per minute with the supply pressure between 35 psig and 87 psig. So this is for the 980, but pretty much all of your ventilators are going to be within that range. You can look on the back side of the ventilator where you have the input gases, and there'll be a label, and that'll tell you the operational range of where your ventilator should be at. This is a very important value to be aware of, because if these parameters aren't consistent or they're out of range, your equipment won't operate properly. You risk damaging your ventilator, harming yourself or others. Here's an example of a faulty tank regulator on an oxygen cylinder that was plugged onto a PB840 ventilator. And you're looking at the back side of the inspiratory module that exploded. So the regulator failed, and it slammed the module with 2,000 psi unregulated oxygen. So again, the acceptable range is 35 to 87 psi, and here it is at 2,000. Exploded. Here there's a oxygen filter and a cap. Shot a hole out the back of the ventilator. Just destroyed everything. I'm sure it was terrifying to whoever was there. Luckily, no one was hurt. Now, on the other extreme, and this is the more common in hospitals, especially here, is that the supply pressure is too low or the delivered flow is not sufficient. So if that's the case, the ventilator will also fail and it'll lock out. I have a customer where this was the case. They had a spike in census. Almost all their ventilators were in service. High flow units were also being used. And the therapist did a short self-test to get their last few units ready, and it failed. So grabbed another vent, hooked it up, did the short self-test, it failed again. Now, mind you, they don't have any more ventilators. He grabbed a third, that one failed, and then the fourth and last one that they had left, that also failed. Turns out there was nothing wrong with the ventilators. It just was that the pipe gas supply in the area where he was testing it was too low. So didn't realize that could have caused the issue, didn't put it together, and now the hospital is out of ventilators and with a pretty big headache on their hand. So two takeaways from this are, firstly, it's not common for a ventilator to fail the same test back to back. Especially if they're being properly maintained, and these are units that are, in a good preventive maintenance schedule. It's just not something that's very normal. Most ventilators will tell you what part of the test failed, so you can use that information maybe to look at it, take a step back and see, if the same test is failing across these units, maybe it's not the ventilator, it might be some external factor that's playing, a part of this. So I'll go into those troubleshooting things a little bit later on in the presentation, but that's just something to be mindful of. And it emphasizes the second point of the importance, and especially now, in fact, we were speaking about this a little bit before coming up, is the importance to have a clear communication between the respiratory department, your biomed, and your engineering. Where everyone's aware of what your med gas requirements are and your limitations are as well. This way, avoid some unexpected problems should you get a spike, and you can react accordingly when the demand arises. So let's look at this. Is the back side of the ventilator, and this is actually where the air and oxygen would connect. And then what I did here is opened up the side of the ventilator and took off the housing so that you could actually see the inspiratory module, and then removed it. To really just show the emphasis here of these two filters. So this is the air and oxygen filters that are filtering your high pressure gas as they enter the ventilator. They're part of the preventative maintenance kit. And each manufacturer has different maintenance schedules for replacing these type of components. For example, the PB980 and the 840 are every 10,000 hours. The Viers is for Avella is once a year. Servo Eyes are every 5,000 hours. But they all really have these filters being changed as part of the servicing process. And why is that? These are the first barrier to getting any contaminants or water into your ventilator. Inside of this vent, it's all mechanical components and electronic components, none of which react very well to foreign contaminants or water or things of that nature. so it's really the most important way to maintain a cost-effective solution to reduce the actual cost of ownership for your ventilator over its lifespan. Think of it as changing the oil on your car. You don't have to do much else, but if you're changing that oil, the car will keep going. Now, it'll drastically reduce your system's downtime. These filters are designed for your patient safety and also to prevent damaging your ventilator. It's a good idea to look at maybe a 6-month preventative maintenance schedule. We'll get into that a little bit more, but it's just a nice thing to be aware of. And now, mind you, you're not going to be changing these filters yourself. Like, this is something that the biomed or whoever is servicing your ventilators would be doing. But it's something important for you to be mindful of, because you're the ones that are going to be able to advocate for your own ventilator and make sure that these guys are actually doing what they need to be doing. So anyway, now the breath continues on, so it's passed through these filters, and it'll now go through proportional solenoids, so PSOLs and flow sensors. So they control the mix of gas that will eventually flow to the accumulator. The accumulator is a tank where your selected percentage of air and oxygen are mixed together and prepared now to the next part of the module, where you have a secondary set of PSOLs and flow sensors that now meter the blended gas and ensure that it's delivering the breath in accordance to your operator-specific ventilation settings. So at this point, I want to point out the oxygen sensor. And again, this is another part that you're not going to be changing yourself, but it is something very important for you guys to be aware of. The oxygen sensor, it measures the percentage of the delivered mixed gas and just it ensures that it coincides with your selected value of FiO2. So it doesn't control it. It's just a safety measure. It's something that's just making sure that, yes, this percentage is in accordance with what we have selected. It's a disposable. So it's an electrogalvanic fuel cell, and they have a finite lifespan. So they're usually replaced every year. Now, why I'm bringing this up is, if you notice on the bottom, it says it contains caustic material. So that caustic material is potassium hydroxide, right? If you look up on the material data sheet, say potassium hydroxide is corrosive, water reactive, causes severe respiratory tract burns, and extremely harmful if swallowed. This is a photo of a oxygen sensor from a unit that was pulled from the floor, just brought off the floor. The white powder here is the potassium hydroxide. So this corrosive material will leak out of the cell if either that cell has been used for an extended period of time. No one's changed it. It could be damaged due to extreme temperature or just be a faulty sensor. It's also possible for this sensor to be damaged and still be operational. So you won't get an alarm on your ventilator. So really, no one's the wiser, but it's leaking out this caustic chemical. And the only barrier now between this sensor and your patient's lungs is the bacteria filter that goes onto the inspiratory module. So that underlines the importance of a consistent preventative maintenance schedule. So for example, if you're following a yearly preventative maintenance schedule, and say for whatever reason it gets missed, we're all human. It's possible that the technician just fails to change it or doesn't notice it, and the unit passes everything else. It gets put back on the floor, and now think between this 1 and 2 year lifespan, how many patients could be put at risk for something that, maybe if it was on a 6-month preventive maintenance schedule, could be picked up a little bit sooner, or at the onset of while this failure is actually happening. And again, this isn't something that you're going to be changing yourself, but it's nice to be able to talk to your service technician and just make sure, hey, when's the last time this sensor was changed, or did you guys change it this way? Just something to have, an extra set of eyes on something on your device. So the mixed gas now leaves the inspiratory module, and it passes through this bacteria filter, through the breathing circuit, the humidifier, and now into the patient. Exhaled gas leaves the expiratory limb, the breathing circuit, and passes through the exhalation bacteria filter. Now we're getting to the side where I think will be more applicable to what we're going to be talking about here, because this is now the area where if there are preventable failures, it's moving here onto the exhalation side. One of the first places that I look at if a unit's with a service tag is or maybe let me say the first place that maybe you guys should look to if a ventilator doesn't pass your SST is at the expiratory filter side. Make sure if it's locked into the ventilator with the locking mechanism. Make sure that there's a secure fit, that everything is snug. Look for cracks. I've come across quite a few units where it was something simply that the expiratory filter fell on the floor, had a small crack on it, and of course now it won't pass the short stop test. Look at the drain cap, make sure you have that in place. All very basic, simple things, but they're quite easy to overlook, and maybe just a once over would help an expensive service call, or having someone have to come up and just change the filter. So here we're into the exhalation valve assembly. So from the exhalation filter now up into this section here. Inside of here is it'll pass through the flow sensor and exhalation valve. And it's this area where PEEP is controlled, excess pressure is relieved, and then the breath is finally released out of the ventilator. For this unit, and pay attention here to these contacts and these contacts here. So the exhalation flow sensor fits snugly, making completing the circuit, and this filter fits inside this cap. Most of the preventative service calls that I get for this ventilator specifically is generated from this exhalation flow sensor. On the 980, unlike the 840, it's easily accessible because it's outside of the plastic housing of the ventilator. So it is easily accessible, so it can also be easily damaged and disappear. You have the flow sensor and the exhalation module. It lowers down onto the disposable exhalation filter. So that's a little bit unique. And what happens is if you slam that latch down, you risk, now go back to where I pointed out those electrical contacts that are communicating between the exhalation flow sensor and the module. You risk making a false contact, or it just comes loose just enough where it's no longer communicating with the ventilator. But it could still be mounted within the ventilator, so it looks like you have this filter here, but it's just not sitting in place correctly. When that's the case, you'll get this error alarm saying reinstall EVQ. And this could be something also that you guys can address yourself initially. So if you see that the exhalation flow sensor is there, but you're getting this air, just turn off the ventilator, wear a glove, and carefully feel under and make sure that that exhalation flow sensor is still there and it's not loose. Just press it up. Close the latch back up and turn on the ventilator. It should boot up without any errors. If it does boot up with some alarm, then pull it and call it in for service. But this could be a simple fix for something that really wasn't a failure on the ventilator. It's just a sensor that came loose. So when you do press your hand to push this up, you have to be very careful not to stick your finger in here. If you do, you'll break that flow sensor. The newer flow sensors that they have now have a plastic X to prevent that from happening inadvertently. But it is something just always make good habit to prevent there. For reference, these flow sensors cost $1,200 plus the cost for calibrating it and having some come out there. So a simple thing as far as just storing the unit with the latch gently closed and with the exhalation filter in place will potentially save you some money and some headaches. Okay, some spare parts to keep on hand if possible. To encourage your biomed department. Keep some batteries, oxygen sensors, exhalation flow sensors, or inspiratory flow sensors. Just a few. Reprocessing kits if you're using this 980. Just some things for them to keep in stock, just so that if there have been a lot of issues with supply chain. So sometimes you're looking at a few months to be able to get components that are critical for your ventilator. So at the very least, if you have a few, it does buy you some time, so you can pull it from stock, place the order to replace that, but keep your ventilators in service without interruption. Now, another tip is if you're using the Puritan Bennett 840 still, good for you. That's a fantastic ventilator. It's a real workhorse. There's one replacement part that I really recommend you having, especially now that these units are quite dated, and it's this part number here. What it is it's a rubber gasket that seals the exhalation filter with the exhalation module. So it's an easy piece to get overlooked. Here's a picture of it, of this gasket. What happens is over time it wears out and it no longer creates that airtight seal, or it just falls out. And again, this is very simple, $35 piece of rubber, but I've had ventilators that have been end-of-lifed because they were, or just retired from the hospital because they were sent to biomed, couldn't fix it, and it turns out all it was missing this gasket, and no one caught it. And I mean, to scrap a ventilator for a $35 piece, it just doesn't make too much sense. So it's just something to be aware of and have on the back of your mind, and it's something that you can replace yourself. It's simply with a flat edge or just with your thumb, wear your gloves. It comes out and you just place a new one up in there. For me, the first time I came across this, it took about a day of just troubleshooting this ventilator, changing flow sensors, calibrating, changing other components, redoing it all, looking for leaks. And in the end, all it was this silly, $35 piece. So now this is the first place I look at if I get any failures on this ventilator. And it's a quite simple place to look, and something that you could help out with. And it's not in plain sight, so it gets overlooked. So it's just something now, if you're aware of, you can talk to your biomeds. If they are unable to fix it, maybe you guys can point a little trick their way. But that brings me to the main takeaway that I have for this is, across all your ventilators, just a real general rule of thumb is keep it simple. Look for the simplest solutions on these units. They're amazing. They're extremely complicated, highly engineered, machines of precision. They have fail safes. They have continuous background system checks, thousands of dollars worth of sensors and components, all of which can be rendered useless with $35 gasket or a $10 defective breathing circuit. So you guys have your hands on these units day in and day out, and you understand what they sound like when you boot them up, how they sound when they're operating, how they feel when you lock in that latch. You can use all of those things to your advantage. When you're troubleshooting something, you can feel it just doesn't feel like there's that airtight seal or that resistance when I close this filter in, or it's not snug. There's something loose there, and those are the things that really will help prevent a lot of unnecessary calls for us to come up there and just say, hey man, circuit, it's loose. So when you run your SST and it fails, check the breathing circuit first. And I know you do, but it's just something that it's worth giving a second look at before it just failing one time and you pull it and call it biomed. Check it. Check and make sure everything's tight, snug. Maybe try rerunning the test and see if that fixed the problem. Look at your disposable filters. Do they have any cracks? Is there any leak between the Y piece and where the filters are connecting to the ventilator? You have your humidifiers. You have a lot of different hoses and points of failure where you can generate a small leak that will fail your unit. Another thing is look at the type of breathing circuit that you're using and make sure that it's the same, that coincides with the patient setting that you're going to use for that test. Are you using a adult circuit, but it was set to a neonate patient? Things like that will fail the unit. So it's worth always just kind of take a step back, look and see what part of it failed, and just double check a few things like that. I know it sounds silly, but is the ventilator plugged into the wall? Is the backside of that power cable plugged into the ventilator? Is it connected to the gases? They're all very silly, simple things, but in the heat of the moment, or you have so many other things going on, sometimes it can be easily overlooked. I think that what it all really boils down to, as far as some of these issues that I've come across, is a proper communication between the person that's fixing your ventilator and the person that's identified the issue with it. So think, when you tag out a ventilator for service, it gets tagged, maybe biomed gets called in, they come, they fix it. But there's never a direct line of communication between who identified the problem and who fixed the problem. So I found that there are a lot of repetitive mistakes that get made that don't get addressed, simply because there isn't that communication. So they'll generate a report, they'll do a write-up, and they'll document that, hey, maybe it was due to a leak in the breathing circuit. But it's an error that keeps coming up over and over. And it leads us to believe that it's not being addressed directly, and it's difficult, to take the time, or it's a lot to ask to have a one-on-one conversation between a biomed department and a therapist, just because both are spread very thin and have a lot going on. But if you do have the chance or the ability to, just brief conversation or a question, hey, what was wrong with the ventilator? What happened? It does go a long way. And I think it will save a lot of headaches or an unnecessary service calls for someone like myself to come up and work on your units. So yeah, as promised, super simple. Just kept it kind of brief for you guys. Thank you for having me here. I appreciate everything that you guys do. You're the front line of a very difficult profession, and you guys really do some miracles here. So if you have any questions or like to discuss any further, I'll be here. We can talk over at the booth. I'd be happy to meet all of you guys and take it from there. Yeah. Yes, sir. Thank you. I think so really what I wanted to touch on there was just a very simple point to identify. If you're replacing your exhalation valves or replacing any components, you do have to recalibrate the ventilator, and you have to do a lot of profound background testings, and then put it on a certifier after and make sure that everything is operating the way it should be. So that enters now the area of the service engineer. It is, I think, very important to have that close communication between your service personnel and your therapist. That way, if it's something that's easily addressed or something that you can just take 2 minutes, check and make sure it's there and fix it yourself, not just fix it, but just correct whatever might have been causing a false error on your ventilator. That's definitely something that's for your realm. When it gets to be a little bit more profound or deeper, that's really when it's, you have to send it out to the biomeds and let them hold on to it. And that delay in turnaround time can be attributed to a lot of different things. Your biomeds are spread very thin. To properly service these ventilators, just for a regular preventative maintenance, you're on average between 1 to 2 hours. And then if you're going to be servicing the unit, you want to put it on so we have an independent certifier. So it measures all of the values of that ventilator with the test log that's sent into the manufacturer every year. And that's your reference point, just to make sure that what the ventilator is actually delivering and measuring coincides with what it truly is. Did I answer what okay. Sure. Mm-hmm. Oh yeah, and because that's a disposable filter. Those internal filters are also disposable, but they're intended for longer term, like on this unit, for example, 10,000 hours. But that disposable filter that's on the inspiratory and expiratory limbs are crucial. You have to have them. For the expiratory side, the ventilator won't work without it. The inspiratory side, it protects your patient, and it also protects the ventilator from your patient. I think the moisture or contaminants that could also enter the ventilator from the front end of it, the patient side. But guys, thank you so much. Take care.